Hello, welcome to video number 171. This one is on similar solids, and the keywords I've got for you are area scale factor and volume scale factor. So in a different video, the similar shapes one, we were introduced to scale factor or linear scale factor or length scale factor. And that is relevant for this video, very, very relevant. And I hinted at the fact that there was an area scale factor and a volume scale factor in that one. But this is what they mean. Now, the area scale factor is how many times bigger the area is than the other shape that you've got. So you'll get two shapes, or at least two shapes, and you'll compare those and have a scale factor between them of the length dimensions. But you'll also have a different scale factor for the area. Okay, and following on from that, you'll also have a different scale factor for the volume as well. So the volume scale factor is how many times bigger the volume of the shape is. Okay. And yeah, that's basically all you need to understand in terms of the language there. The method states the area and the volume scale factors are linked to the linear scale factor. You find that and you can work anything out. Okay, to find the area scale factor, you need to square the linear scale factor to use, and then you use that to solve the problem. To find the volume scale factor, you need to cube the linear scale factor, and then you can use that to solve the problem. You may need to think about cube rooting or square rooting. It depends if you've got the area scale factor or the volume scale factor already. And if you do square root the area scale factor, you'll get the linear scale factor, which you might need to get in order to get the volume scale factor, for example. And then the same thing for if you've got the volume scale factor, if you cube root that, you will get the linear scale factor. So it all sounds quite complicated, but actually it's three. It all revolves around that linear scale factor. Look out for ratios is what I've put in pink there, because look out for ratios. So in number 1 below are two similar pentagonal prisms. Right? There is no formula to work out the volume, the area of a pentagonal or a pentagon. So therefore, there's no formula for working out the volume of a pentagonal prism, but they are similar to one another. Now the volume of A is 25 centimeters cubed. The volume of this small one is 25 centimeters cubed. So I could write that there, just over the top of it. That's our volume. All right. We've got to work out what the volume of B is. Okay. Now, this does require a calculator, I feel. Most of the time you'll get these on calculator papers. So let's bring our calculator in. And what we've got is the length on the bottom and the corresponding length on the bottom of the bigger one. Okay. Now we can do 12 divided by 4 to find what the length scale factor is, the linear scale factor, right? And that would be 3. Okay, that is our linear scale factor. All right, you don't have to write that down, but that's just me showing you that's a nice thing to know. All right, the linear scale factor. What we then do with our linear scale factor, because we want the volume, is we cube it. Okay, now 3 cubed, 3 times 3 times 3 is 27. Okay. And you can always use your calculator, 3 cubed, if you want, all right? And then once we've got that, we know that's our volume scale factor. That's how many times bigger this volume is than this volume, okay? The volume's going to get bigger a lot quicker than the lengths do, all right? And the same for area. So the volume of that is 25 multiplied by 27. 25 centimeters cubed multiplied by 27. Okay, that's our scale factor that we found for volume. So we get that 27 and we multiply it by the volume of the smaller one, 675. So 675 centimeters cubed is the volume of B. I hope that makes sense. All right, it's grade 7. It's higher only. But obviously, it revolves around that linear scale factor, which is from foundation maths. Now, B, the surface area of B is 360 centimeters squared. What is A's surface area? So the whole surface area, all the area of all the faces of this pentagonal prism added together is 360 centimeters squared. All right. And we don't know what this is, but we do know what the scale factor is. Okay, again, this time we're thinking of squaring the scale factor. So if we do the calculation, it's 12 divided by 4. If this was a question in its own right, we'd have to do 12 divided by 4 to get that 3, the linear scale factor. All right. Then what we would do is we would take the 360 sorry, no, we wouldn't. We'd get the area scale factor first. So we'd square that. Okay, that would give us 9. So 3 squared is 9. That is our area scale factor. And then what we would do, take the 360, and we would divide it by 9, because we're finding the surface area of the smaller shape. And if you want to find the smaller shape's area, you're going to have to do division. If we wanted to find the bigger's area or volume, we'd have to multiply. All right, so doing that, that's going to give us 40. That's easily done without a calculator. All right, and let's just use our units here of centimeters squared for the answer. All right. Squeezing it in is a little bit painful, isn't it? But I don't have enough room to do it. But I wanted to put 2 questions in there, one for volume, one for area, revolving around these things. Okay, so the surface area of this one, 40 centimeters squared. The surface area of this one, 360 centimeters squared. All right, hopefully all of that makes sense, revolves around knowing that you can square or cube to get the area or the volume scale factors. Okay, number 2. A little bit more context in this one, a little bit trickier. Cone A and cone B are mathematically similar. Good news, happy days. Right, we should state this in the question. Otherwise, we'll have to think of another bit of maths to work something out, probably. So the total surface area of cone A is 120 centimeters squared. The total surface area of cone B is 1080 centimeters squared. The diameter of cone A is 8 centimeters, as we can see on the diagram. Work out the diameter of cone B. So this is all going to revolve around the area scale factor. So to get the area scale factor, how many times bigger one is than the other, all right, we just do the bigger one, so 1080 centimeters squared, and we divide it by the 120 centimeters squared. All right, again, could be done without a calculator. 1080 divided by 120. There we go, 9. So the area scale factor, I'll just write it in, equals 9. Okay, now this is a question where we've got the area scale factor and we want the length, the linear scale factor. All right, so we're going to square root that 9. Okay, and when we square root something, we get 2 solutions, yes, but we're going to ignore the negative one. We're going to use the positive. All right, so 3, I don't know why I've put those 2 lines there, they mean nothing. All right, 3 is the linear scale factor. Like I said, if you work that out, you can work anything out now. So we know that this length here is 3 times bigger than this length here. So all we have to do is 8 centimeters multiplied by 3. That's going to give us 24 centimeters. So the diameter from here to here didn't work. It wasn't anything more. It wasn't the radius of the big one or anything, right? If it was, we'd have to half that. But that is 24 centimeters in length for the diameter of that cone. All right. So it's, like I said, it's all revolves around that linear scale factor. So have a look at the third and final question in this video. So solids X and Y are similar. No diagrams in this one. The ratio of the volume of X to the volume of Y is 64 to 343. Okay, so we can get the volume scale factor from this ratio if, because we've got the volume of one to the volume of the other, right? If we do the division of this divided by this, all right? Surface area of X is 176 centimeters squared. Work out the surface area of Y. Okay, so we're going to get the volume scale factor. That's what we're going to get if we've got the ratio of the volume of X to the volume of Y, right? We do 343 and we divide it by 64. Okay, that's because we want to find out what the volume scale factor is. How many times bigger one is than the other. Okay, and 343 divided by 64. Okay, you could write that as a ratio, right? So 343 over 64 is the simplest form we get. So what I'm talking about really is 64 to 343. And these are nice numbers. These are cube numbers, by the way, if you hadn't noticed. All right, 4 cubed and 7 cubed, right? And they tend to do that with these sorts of questions. But yeah, what we're doing is we're dividing both of those sides by 64. So we're getting 1 to 343 over 64, right? Ratio of 1 to n. How many times bigger is this than this, right? And that's how many times bigger it is. So that is our volume scale factor. All right. Again, you don't always have to write this as just for your benefit and for my benefit. When I'm doing my working, I like to think, oh, what was that? All right, that was my volume scale factor. Okay, so I've got my volume scale factor. and what I need is the linear scale factor. Okay, now the linear scale factor is cube root in both of these numbers. So we're going to get the cube root of 343 over 64. And like I said, these are both cube numbers. So actually, they will both cube root nicely. And that will be 7, and that will be 4. Okay, you don't need the calculator for that. But if you had a calculator, it'll be worth using. So cube root of, I'll just show you what I'm talking about, 343 over 64, 7 over 4. All right, so that's our linear scale factor. All right, that's how many times bigger the lengths are on the solids, or the solid y is bigger than x. So that's how many times bigger the lengths are on solid y compared to solid x. Okay, so the surface area of x is 176 centimeters squared. So what we need is the area scale factor here. So we're going to square both those numbers. So 7 over 4 all squared is going to be 49 over 16. 49, that's our area scale factor. So we're using all three things here. All right, and then we can use that number and multiply it by this, okay, because x is the smaller one. And yeah, we can tell that from the ratio there, right? Then we're going to multiply the 176 centimeters squared by the 49 over 16. And that's going to be our answer. So I'm just going to square that on the calculator. Okay, 49 over 16, and then multiply that by 176. That gives us 539. And that is our final answer in centimeters squared, because that is what we wanted. We wanted the surface area of y. That is the surface area of y. All right. So a tricky last question, for sure, involving that ratio a little bit. And I don't think it really gets much more complicated than that at GCSE level. So hopefully it's all made sense to you. Thank you for sticking with me and watching this one all the way through to the end. I hope you click the link in the description and practice, and I hope you have a lovely rest of your day. Thank you so much. Bye-bye.